Let's do an example here of vector addition where we have two vectors and are looking to solve for the resultant vector c. So first of all, let's look at what we're given. We're given the starting and ending points of each vector, which means we have everything that we need to solve for the components. So let's do that. Let's start with A and do one vector at a time. So the x component of A is the x value of the ending point minus the x value of the starting point. So AX is 3, and same goes for the y component. You get the y component of the ending, the y point of the end, minus the y point of the beginning. And so here are your two components for A. Now let's do B. The x component of B is 5 minus 3, which is 2. And then the y component is 6 minus 2, which is 4. So now we have the components of both of our vectors which we're adding together. And so to find the components of the resultant vector c, we simply add the x and y components of each. So we'll find the x component of our resultant c is just ax plus bx, or 3 plus 2, which is 5. Same for y. cy is 2 plus 4, which is 6. So we have our two components now of our resultant vector, which if I draw it in red is just this giant triangle here. So cx, cy. So now, given that we have solved for these, what we're looking for is the resultant vector c, meaning we need to find the magnitude and the direction. So given that we have both components, we can now use Pythagorean's theorem to solve for the magnitude. So I'll write that over here, that c, magnitude of c, is cx squared plus cy squared. And plugging numbers in, that's 5 squared plus 6 squared, which is equal to the square root of 61, or writing in decimal form, that is 7.8. So that's our magnitude. Now we have that. Now we need to find the direction. So the angle, which is the angle of the big triangle here with respect to the x-axis. You could do it with respect to the y-axis too, but it doesn't really matter. The way I've drawn it makes it easier to visualize it this way. And it's just conventional, I guess, to do it with the x-axis. So we want to use our trig functions here. So which ones can we use? Well, we know cx, we know cy, and we know c. So we could really use any of them. All three of them could be used. I'm going to pick tangent of theta, which would be cy over cx. And I'm doing this, it doesn't really matter at the end of the day, but I'm doing it because there was one less calculation we did to reach it, to reach these numbers. We had to do an extra calculation to get uh, the magnitude, which, if you made an error in here, it could result in a wrong answer here. So it's just, it doesn't really matter, but it's good to think about those things sometimes. So we'll solve for theta by using our arctangent function, our inverse tan. And then we can just plug our values in. It would be arctan of 6 divided by 5, which in radians, if your calculator is in radians, it would come out to 0.87 radians. But we can convert this to degrees if you just take your radians, multiply it by 180 degrees, divide by pi. Some of you may have had your calculator in degrees already, so you can skip this step. But it works out to 50 degrees. 50.1 or so, but I rounded it to 50. Okay, so we have this angle now, and it's with respect to the x-axis in the first quadrant. So if we consider our compass, this is north, this is east, and our angle is here. So that means this is north of east, 50 degrees north of east. Therefore, our final answer is our magnitude of 7.8 at 50 degrees north of east. So that's how you use vector addition to solve for a resultant vector. I'm going to do more examples in the next video, similar examples with slight differences, but that's how you do this one. Thanks for watching.